For my project, I wanted to try and predict a death event of heart failure for at-risk patients. So I'm going to go over my motivation behind choosing this project, the data set I use, my research questions, as well as my whole model selection process, including the pre-processing steps, the algorithms and search, metrics. I'll go into some feature importance, and finally go over results, conclusions, and suggestions for future work. The data set I use comes from Kaggle. It's the heart failure prediction data set, and it's a collection of at-risk patient data, 299 observations of it. The target in this case is death event, where 1 indicates a patient dies and 0 indicates a patient was censored. Censored merely means the scientist in charge of the study lost contact with the patient. It doesn't provide any information on whether they lived or died. Additionally, the data set is composed of both numerical and categorical variables, although the categorical variables are pre-encoded, as you can see indicated by the binary 1 and 0s in categories such as high blood pressure. There are obvious features in this data set, but I wanted to take some time to go over some of the more biologically heavy features just because I think they're relevant to understanding this model. So first, ejection fraction is the percentage of blood being pumped out of the left ventricle. As you can imagine, if your heart is having difficulties getting enough blood out, that's basically the definition of heart failure. So I really expect ejection fraction to be a significant predictor in this case. Additionally, creatinine phosphokinase, that is an enzyme found in the blood, which is indicative of muscle damage. So if we see super high values, that may be indicating that the heart isn't functioning properly, given that the heart is the strongest muscle in the body. Finally, we have serum creatinine, which is another enzyme that's actually indicative of kidney failure. And this is linked to poor cardiac output in that if your heart fails, then all your other organs are going to fail too. Next slide. My research questions are: 1, can we predict a death event, heart failure, for at-risk patients based on a variety of these biological markers and categorical features? Additionally, which of these features are most important in predicting a death event? So just to go over some of my pre-processing, for my continuous variables, I use standard scalar to normalize them and improve the efficiency of our ML models. And then, although we didn't have any missing values in my data, I still wanted to utilize a simple imputer for both categorical and continuous, being that if we're going to test it on a patient's data, we may not have all that information. So I wanted to include that in the pipeline. And so as I said, the categorical variables are already hot encoded. So I didn't need to do any pre-processing regarding that. And I noticed there was a slight class imbalance, about 60% class 0 as opposed to 40% class 1. So I wanted to utilize weighted metrics to help with this slight class imbalance. And as you can see, this is just a snippet of my pre-processing steps. So for my algorithms and search, I focused on 3 main algorithms that I learned in 621 and 699 that are geared towards binary classification. I looked at logistic regression, random forest classifier, and k-nearest neighbors classifier. And I use random search CV, which tests all these algorithms and ranges of hyperparameters via cross-validation of metric. And the metric I used in this case was F beta score. And as you can see, I use averaged equals weighted, as I mentioned, for the class imbalances. And the reason I use F beta is it allows you to put more emphasis on recall or precision. In this case, I increase my beta, which puts more emphasis on recall. And this is important because we definitely want to, since we're dealing with human lives, we want to be better safe than sorry. So putting more emphasis on recall minimizes false negatives. So that's really important in this case. And when I ran my random search CV, I found that the random forest wins. It had a 0.744 F beta score in the cross-validation. And these are the ideal hyperparameters I found. When I tested it on the test set, I found that we got an F beta score of 0.76, which is still good, and a balanced accuracy score of 0.718. So it seems like our model is predicting fairly well. However, when I looked at the confusion matrix to see which classes it was performing well on, I found that it had a much higher recall for class 0 as opposed to class 1. Uh, I don't necessarily know why this is, but it's kind of unfortunate. I would rather have those two values flipped, being that we're trying to predict death events. So that's definitely something I can improve upon, or this model can be improved upon, is trying to really increase that recall for class 1, being that that's our main goal. So my second question was which of the models or which of the features are most important. So to do this, I utilize SelectFromModel, which allows you to specify a max number of features. So I fit this on my chosen model only to get the three best features to figure out what they are. I was really just kind of interested in, which ones are most significant. And I found that age, ejection fraction, and serocreatinine were the top three. And ejection fraction and serum creatinine makes sense to me, but age is definitely one that, while I imagine it does have an influence, it's a little surprising that it comes in the top three over things such as like smoking and some of the other biological markers. Additionally, it seems like the numeric values contribute way more than the encoded categorical features. So I'd be interested to see if the model would perform better if I just ran it without the categorical features, being that it doesn't seem like they have much of an influence. So to summarize, I was able to build a model that performs okay at predicting a death event. Its recall wasn't great at 0.61 and definitely has room for improvement. Like I said, we have good precision and recall with class 0, whether or not a patient is censored, but that's not really what we care about in this case. We care more about predicting whether a patient is going to die. So future work, I'd like to improve this model to have better recall for class 2. And as I mentioned before, maybe I'll just see how the model works with the three best features, see if that results in better classification for these two binary classes. And thank you very much.